I would like to introduce you Noel Lovisa, who is the CEO of Code Valley, an Australian-based software company. Noel holds a Master's of Computer Science from James Cook University from the year of 1994. Noel defines himself as a technology entrepreneur and a Bitcoin advocate. The title of his talk is "The Software Industry is Not Industrialized." Welcome, Noel.
"50 years ago, Douglas McElroy stood before a conference in Gurmesh, Germany, and declared the software industry is not industrialized. Today, 5 decades later, his vision of a mass-produced components industry is yet to emerge. What does it mean to industrialize the software industry? Well, consider this: true developer parallelism. And by that I mean if a single developer can create a project in 30 days, true developer parallelism will allow 1,000 developers to complete the same project in 30 minutes. Impossible, right? True developer parallelism is one of many extraordinary benefits of a software industry that's industrialized. Good morning, ladies and gentlemen. My name is Noel Lovisa, and this morning I'm going to outline why it's so difficult for us to specialize in our industry, what we have done to overcome those difficulties, and besides true developer parallelism, what can we expect of a software industry that's industrialized? It turns out that it's remarkably easy for me to specialize in our industry. It's just virtually impossible for me to build a viable business as a specialist. I would starve as a software specialist in our industry. Other industries have the benefit of tangibility to protect their prospects of repeat business. We don't enjoy that particular feature in our industry. And also, we must move away from the model where you're creating many thousands of features in a software project and move to a model where you create a single feature in many thousands of projects. Not exactly a walk in the park achieving that. But it actually gets worse, because if you're creating a single feature in many thousands of projects, it implies a reversal of integration responsibility. It's now your responsibility to integrate your part into my project. Quite the opposite of today. And if that wasn't hard enough, integration today is a rather crude affair. Take this binary. I'm going to be very simple here, so I'll gloss over a lot of details, but essentially we just append our routine object, bean, component, whatever, to the binary, and we create references and data structures to it in glue code, which introduces a centralism that is forbidden if we're going to create a software industry. Not only must you share the burden of integration, but you must now adopt an integration policy, the far more difficult integration policy of seamless integration. Seamless integration means you must touch the binary in many places in order to install your feature into my project. And it gets worse. We want to scale to industry level. So a practical feature means many thousands of places, and of course, serious features may entail you touching the binary in many millions of places. It seems beyond impractical. And if that wasn't difficult enough, seamless integration implies real-time custom fragment design, and it implies real-time custom fragment design of all the other specialists participating in the project as well. And on top of that, you've got to achieve that feat without complete project contextualization. You can't be given complete access to my project. We need you to only focus on the bits that you precisely require in order to protect the intellectual property, your intellectual property, and those of all your peers. It's fortunate that Doug is on a panel tomorrow afternoon, because I can ask him this question, what was he thinking in 1968 to advocate software industrialization? If we can achieve all of these extraordinary difficulties, then it becomes a piece of cake. It's just the most complex classification scheme that's ever been devised, with its attendant forum and gathering of metrics and pricing data and so forth. And of course, the most formidable mechanism for remuneration that the world has ever seen, that can operate in 150 countries with 150 currencies, with AML and CTF and a host of compliance issues. Good Lord. In the next few slides, I'm going to articulate a bunch of innovations and constructions that surprisingly achieve or overcome all of these impediments to industrialization. I'm going to vindicate McElroy's approach of 1968. The first construct is called a construction site, and it's a communications channel that provides access to my project so that you can install your feature. And despite the incredible burden of seamless integration and the like, the construction site protocol is just simple and elegant and consists of a three-step process. The first is you request a space be reserved in the binary, some space for code and data. That's right, we're building the binary directly with industrialization. Next, I supply you with a physical address of where in the binary that space resides. The last step is then you supply bytes of code and data that I use to render those reserved spaces, thus completing the binary ready for acceptance testing. It's really quite a simple protocol. But as you can imagine, you're going to need a lot more than just a construction site in order to deliver your feature at those industrialized scales into my project. You're going to need a whole bunch of additional requirements. Take, for example, a very simple feature where you're adding, say, a constant to a variable. Typically, you'll need to know what that constant is and where in the binary to find that variable. And for reasons that will become obvious in a moment, we also reverse the requirements responsibility. I'm not going to give you those requirements. You are going to give me degrees of freedom. I must choose requirements from within the range of on offer in order for a contract to you to be acceptable. This has big implications for requirements engineering and the like. It makes everything in this industrialized world constructible. Surprisingly, this parameterized requirements is actually common practice in all other industries. We saw Ericsson on here as a keynote speaker recently. I can't buy a 32.5 amp circuit breaker from Ericsson. They make 30 amp and 35 amp. I must choose from a range that they set in order for my project to be constructible. Also common in other industries is to harness the suppliers themselves to determine some of their requirements. Take, for example, this particular example. I haven't shown all the degrees of freedom, but we've got one supplier who's designing a fragment of code to perform a multiplication, and another designing a fragment of code to add two numbers. It's common practice for us to put these suppliers in touch with one another to determine some of their requirements themselves. Now, even though this very simple construction site protocol only allows you to deliver a contiguous fragment into the binary, The combination of this construction site and degrees of freedom mean that you can touch the binary in other places other than your fragment. The multiply guy arriving in agreement with the add guy on the transport of that variable is influencing what the add guy is delivering, and vice versa. The add guy is influencing what the multiply guy is delivering. Surprisingly, the combination of this very simple construction site with these degrees of freedom permit you to still approach seamless integration. Next, I'm going to borrow one of the most awesome drivers of the Industrial Revolution. It's automation. Automation is what drove the Industrial Revolution to be a revolution. And automation is not going to, is obviously going to be very significant here as well. Automation, if you're specializing, it's very easy for you to automate your specialization. And an industrialized approach, it's all specialization. Automation has much greater purchase in an industrialized approach. And automation will not only greatly increase your productivity, but it allows you to host many contracts at the same time. Or put another way, allows you to participate in many projects at once. Automation. We can construct an agent using that automation. An agent provides your service on your behalf. An agent will accept the contract with its attendant construction site, open the communications channels for those degrees of freedom and arrive at those various agreements, deliver the fragment, get remunerated and close out the contract automatically. A developer deploying one or more of these agents is inheriting a superpower, a developer superpower. You're going to hear a lot more about agents, I fear, moving forward. Another construct that we are now going to steal or borrow or inherit from our fellow industries not only allows your agent to deliver features that require you to touch the binary in many thousands of places, but can allow your agent to deliver those very high-end features where you need to touch the binary in many millions of places. And this construct is also in common use in all other industries. Subcontracting. Now your agent can subcontract fragments from other agents, which can be simply combined to deliver your obligations, your fragment obligations. Subcontracting, if we're using subcontracting, the construction site protocol remains unchanged. Now you have suppliers, and those suppliers are going to request some space be reserved in the binary from you. It's a simple matter now for you to aggregate those requests and forward a single request to me. When I deliver your physical address for your space, it's a simple matter for you to compute the physical addresses for your suppliers. And when your suppliers deliver their fragments, it's a simple matter for you to concatenate those fragments. They will be designed to work together with concatenation. So it's a simple matter for you to concatenate those fragments for delivery of a single fragment to me. Surprisingly, in a literal sense, subcontracting allows your agent to deliver a fragment totaling many, many millions of bytes in size or many millions of function points in capability from a process that is locally simple. Your agent merely has powerful contractors. Well, actually, those agents are locally simple as well. Indeed, regardless of the size of the feature you're delivering into my project, whether it's going to touch the binary in a dozen places or a dozen million places, all agents are uniformly simple, locally simple. It's quite an extraordinary outcome. What this means is that industrialization has complexity as an emergent property. Regardless of the size of the project, locally, throughout the project, all these agents and contracts are locally simple. McElroy addressed a NATO conference in 1968. NATO, a military organization, the largest projects on the planet are typically military projects. It's a little surprised that NATO smacked into the software crisis first. When you consider that 2/3, even today, the metrics are horrific. 2/3 of large-scale systems fail outright or are delivered as a fraction of what they originally intended. The big end of town in terms of software development is hard, very hard. What you may be looking at here is the only software development technology capable of reliably delivering these large-scale systems. Whether a project consists of 100,000 agents or 100 million, size now just means a linear increase in cost and resources. Thank you, Douglas McElroy, and thank you, ladies and gentlemen.
Thank you, Noel. I have also for you Swedish specialties straight from the great city of Gothenburg.
Thank you very much.
Thank you. Ladies and gentlemen, Noel Lovisa. And